So today, and a lot of what we're doing this week is just going to be working with some of the basics of things that you've worked with Algebra 1, and a lot of this is going to be some reminders, but to get us back from the start of your Algebra 1 book, ready to really get rolling in the Algebra 2. And a lot of Algebra 2 is just more of the same stuff in Algebra 1, it's just extending it. Right? When I talked to my pre-calc class, I said pre-calc it's basically it's just another algebra class, except it's on steroids. Okay? You guys see that commercial? And I can't remember what the product they're selling or whoever it is, but it's one where the two guys are lifting weights and the one stays the same size and the other guy keeps getting, every time he says bro, whatever, he keeps getting bigger. Okay? All right? Well, when he's at his max, that's pre-calc. All right? And when after he's lifted once, he went from Algebra 1 to Algebra 2. Okay? So it gets a little bit tougher, but it's not incredibly hard at the beginning. As you get towards the end, it gets a little bit tougher, but pre-calc's when that guy gets to the max. All right? That's the big difference there. So, all right. So here we got PEMDAS. All right? What are PEMDAS? Who remembers PEMDAS? All right, Stephen, what are they? All right, great. Okay, order of operations. All right. So we have to make sure we do things correctly when you're doing order of operations. All right, like you said, parentheses, exponents, multiply, divide, add, subtract from left to right. All right. So here we're going to evaluate to start. So when we evaluate, that means we're going to take what these letters equal and we're going to substitute them for that letter. Biggest thing to be careful with is negatives, all right? And especially if you have a power. So make sure when you raise things to a power, you do it correctly if it's a negative. And because we ran into that situation when we were doing the quadratic function, all right? Because some of you, you realize that if you didn't put a negative in there for b when b was negative, if we didn't square it correctly, we would make mistakes. Okay? So we got to make sure that, first of all, we write it correctly. Second of all, we do our exponents correctly. So k is negative 1 plus 6 times negative 6 plus negative 2. Right. So since parentheses are first, we need to do what's inside the parentheses ahead of time. So I'm expecting, so let me say this, is that when we get to the test on this stuff, there's probably going to be a no calculator part again. All right? To freak you out now. All right? Let you know that ahead of time. So some of these things you should be able to do it, because basically all I could do, I could just stick that all in my calculator. I could, do you know that you could actually define these variables in your calculator and then just put in h plus 6 parentheses h plus j? All right, your calculator would do that. All right, you could store those numbers in, plug them in, and do it. Okay, how many knew that? All right, we have one. All right, your calculator would do those things. So anyway, do the parentheses first. Negative 6 plus negative 2, negative 8. All right, so these take some steps, so you need to make sure you do the steps correctly. All right. Now, here's where there's a lot of mistakes made. Some of you want to do this first. You can't do that first because this is an addition sign where this parenthesis means what? Multiplication. So the multiplication has come before the addition. So this is negative 1 minus 48. So negative 49. So you've got to make sure that you do those in the correct order. Okay? Okay. Number 2. Plug the things in. Z is 2 minus x is negative 6, y is 3, and to the third power. All right, so P comes before E, right? Not in the alphabet, but on PEMDAS. Right? So we have to do what's in the parentheses first. This is another place where people make mistakes. Oh, negative 6 to the third power, I can do that. 3 to the third power, I can do that. Great, but that doesn't mean anything. You have to do what's in the parentheses first. So 2 minus, and negative 6 plus 3 is negative 3 to the third power. So now we have an exponent that we can use. What comes first, the exponent or the negative in front of the parenthesis? Okay, Ms. Fish? The exponent. All right, so negative 3 to the third power is negative 27. Because if that power was even, it would make a difference here. All right, since it's odd, it doesn't. But if it was even, we'd end up with a positive number inside the parentheses still, not a negative number. Right? So we get, what's the opposite of negative 27? All right, so 2 plus 27 equals 29. All right. You can do all of this on my calculator from step 1. 2 minus parenthesis negative 14 plus parenthesis negative 4, close the parenthesis, square it, close the parenthesis on the outside. Okay. Now, if you want, you can use brackets too to help you. All right, if you want to add more than that. Okay, but that's all it is. Okay, and as long as you set everything up right, I can type one statement into the calculator and it should come out the same as what I get. Okay, and if it doesn't, then you need to check, see what you did. And I don't know how many other people we had, Adam was trying to put these together before he actually squared it. And you've got to remember that since I'm in the parentheses with the exponent has to happen before I combine things in the parentheses. Because inside the parentheses, here's a plus sign, right? Okay, what comes first, the plus sign or the exponent? Exponents, then adding. Okay? All right, so you got to remember that. Okay. All right, combining like terms. Here you have the statement 4x squared plus y squared plus x plus 5y squared. So to be able to do these, you should be able to know, or you should know, the following words. Term, what that refers to, what an expression is, variable, constant, and coefficient. All right, and actually, I need to add one thing up here. We'll make it a 7. All right, so from that statement up there, 4x squared plus y squared plus x plus 5y squared plus 7, give me an example of each of those things. Of a term, an expression, a variable, a constant, and a coefficient. So what would be an example of a term? Courtney, do you know? 5 would not be an example of a term. Good try.
5y squared.
Okay. 5y squared would be an example of a term. Okay. The question is, how many terms are there up there? Okay. There are 1, 2, 3, 4, 5. Every time there's a plus sign or a minus sign, they separate terms. Okay. So all the terms would be 4x squared is a term, y squared is a term, x is a term, 5y squared is a term, and 7 is a term. Okay? Anything separated by a plus or minus sign is a term. Okay? All right, how about an expression? What's an expression? All right, Gracie, how about an expression? The whole thing would be an expression. That is correct. Okay? Because an expression is a group of things that are separated by pluses or minus signs. Okay? So the whole thing is an expression. Or I could say that 4x squared plus y squared would be an expression. Okay? Yes, Caleb. Okay. All right. Variable. How about a variable? Okay, x is a variable. So we have two variables up there, x and y. All right. So let's see here. Let's write a little bit. Okay. Term. All right. The whole thing we said is an expression. Variable would be x or y. Oops. All right, how about a constant? Okay, 7 is a constant. Constant's a number by itself. All right, 7 would be the only constant up there. All right. And how about coefficient? Keegan, you know what a coefficient is? What? Michael? Just a number? Kind of. All right, but it's got to be a number in a specific spot. Okay. All right. All right, Natalie? Right, number beside the variable, in front of the variable. So in this case, 4 is a coefficient because it's in front of the x squared, and 5 is a coefficient because it's in front of the y squared. Is there any other coefficients up there besides 4 and 5? 1. Yeah, 1 is, okay? Because 1 is the coefficient for the y squared term and the x term. Okay? So 4 or 5 or 1. All right. Okay, simplifying expressions. So PEMDAs come in play here. So we have 5w minus 3w times the quantity, 3w plus 6. So we start with our parentheses. Okay, 3w plus 6 is 9w, right? Okay, they're not like terms. Can't put them together. Good. Okay? So, we had parentheses. Can't do anything. Do I have multiple? Do I have no exponents? Do I have multiplication? All right? The multiplication is the negative 3w times 3w plus 6. So now we got to do the multiplication. 5w minus 9w squared minus 18w. All right, we have to distribute the negative 3w to the 3w plus 6. There's the multiplication. All right, now we can add like terms. So what are like terms in this situation? All right, so there are a pair of like terms because these two both have just w to the first power, which means I can put them together. So 5, what am I going to write first then? Should I write my 5w minus 18w, what that equals first, or should I put the negative 9w squared first? Okay. Always put the thing with the highest power first if it's an option. Okay. So we're going to put the negative 9w squared minus 13w. All right, that's called standard form. All right, when we put the thing with the largest power first. We always want to write things with largest power first. Okay. All right, number 6. All right. First, we look in the parentheses. Can we simplify anything inside the parentheses? 4 plus 3b, not like terms. Negative 7b and 5, not like terms. So we can't simplify anything there. So we're going to multiply. Distributive property, negative 36 minus 27b plus 21b minus 15. All right, so here we have things with b's and things that are just constants. So when I write my answer, I want the b's to go first because b has a power of 1. The constants have a power of what? 0. Okay? All right. B has a power of 1, but the constants have a power of 0. So negative 27b and 21b is negative 6b. Negative 36 minus 15 is negative 51. Okay. Make sure you're doing order of operations correctly there. All right, so writing algebraic expressions. All right, so on the bottom of the last, we're going to be doing the last thing on the bottom of that page, so don't turn it yet. All right, this is stuff I've added to help you here. Okay, there are 3 different ways in which a basketball player can score points during a game. Free throw, 1 point for a free throw, 2-point field goals, and 3-point field goals. An algebraic expression can represent the total points scored during a game. All right, so we have 1F because that gets 1 point, 2G because that gives us 2 points per field goal, and 3T for 3 points for every, what do they call it? A tray, right? Right. So if we make a 3-pointer, sometimes they call it a tray. Right? So identifying or being able to write expressions correctly help us with a lot of real-world problems. Right? Back to those story problems that you love. All right. The action might mean to combine something, and what are you going to do? You're going to add. What might it say in the question? How many is the total? Okay, how many are there? What's the total? Find the sum. Okay, or we're going to combine equal groups, which would mean that we would multiply. How many are there all together? Okay, what's the word for multiplication? What's that P word for multiplication? Product. Okay, find the product. All right. If we want to separate things or subtract them, how many more are there? How many remaining? Or what's the difference, right? Okay. Separating the equal groups, we're going to divide. So how many are there in each group? What's the division word? Quotient. Okay, find the quotient. All right, so sum, product, difference, quotient, and many other ways those can be written. All right, so here's a couple examples that I have up here that are not on your paper. All right, the number of apples in a basket of 12 after n more are added. Okay, so how would I write that expression then? All right, so here we're making expressions. What would that expression be? Who knows? All right, Kayla. Okay. Is it multiplication? 12 plus n or n plus 12, either one of them is correct. All right, 12 plus n, they're adding them together. Okay. Letter B, the number of days it will take to walk 100 miles if you walk m miles per day. So are we adding, subtracting, multiplying, or dividing here? Okay, so what would it be? 100 divided by m, or 100 over m. Good, Justice. Okay. All right, so those are the types of situations. So here you have this little application problem here for you to write this. Mr. Bean drives a scooter. I don't know who Mr. Bean is. He says, no, seriously, he really does. Suppose his scooter currently has 8,200 kilometers on it. So he must ride his scooter in England. Okay, you guys have all heard of Mr. Bean, right? No, probably not. He's really old. Okay, his scooter has 8,200 kilometers on it, and he plans on driving the scooter 36 kilometers per day. Write an expression for the number of kilometers Mr. Bean drives on his scooter over time. All right, so what would that be? Write an expression for it. Okay, last thing, well, there's two things left. We'll get through these quick. Okay, least common multiple, LCM, least common multiple. What does it mean? Okay, smallest number they all go into. All right. Smallest number they all go into. All right, the LCM. All right, so what's one way I can find the LCM? The one would be the greatest common factor. Okay, the GCF. Okay, so here's the difference. Okay, all right, and this is, it gets confusing that way. GCF, greatest common factor, we think, oh, that's a big number. Okay, LCM, we think, oh, that's a small number because it says least. Okay, but least in this case is talking about smallest number they all go into. All right, so the best way to do this would be to write them out. Okay, I got the number 6. 6, 12, 18, 24, 30, 36. So write the multiples. Okay, and then we're going to find the smallest one that all three of them have, or that all of them have. Okay, 5, 10, 15, 20, 25, 30, 35, so on. Okay, then we can do that with the 3s. All right, well, so far, 5 and 6, the smallest number they both go into is 30, right? Does 3 go into 30? Yep, 10 times, right? So the least common multiple for these is going to be 30. So basically, you can write the multiples of those numbers, list them out, and then just look for the smallest one that they all have in common. Okay? Sometimes that's just the product of the numbers. Okay? If the numbers are prime, like 2, 3, and 5, the least common multiple is just the product of them. So what's 2 times 3 times 5? 30. So the least common multiple for these is 30 also. All right. So if they are primes, the least common multiple is just the product of all the numbers. Okay. If they're not, then you need to list them. All right. All right, so you guys do 7, 1, 2, and 4. Okay, last one then. Distributing through fractions. We love fractions, right? No, we don't. You should. Should love fractions. They're great. They're wonderful. Okay? They're easy. All right? 12 times that. You know what's nice about 12 times that? All of those denominators are factors of 12. Okay? So you have two options here. One is to understand that they're all factors of 12. The other is to remember that this is 12 over 1. So, if need be, I'm going to do this twice. Or actually, I'm going to do 9 one way and 10 the other way. Okay? I'm going to do 9 as if I don't know that those are factors of 12. Okay? So, 12 times 2 is 24. So we have 24 over 3x minus 12y minus 12 over 4y plus 60 over 6x. Okay, so what did I do? Okay, multiply the numerators. All right, that's all I did there. Okay, now I'm going to simplify each fraction. So we get 8x minus 12y minus 3y plus 10x. Right? So I distributed the 12, simplified the fractions, and now I'm going to combine the like terms. So which one should I do first now? Because I don't have a powers that one power is greater than the other, right? All right, Michael, which one?
Would it be the x because 1 before y?
That's right. I'm going to put the x first because it comes before y. 8 plus 10 is 18x. Negative 12 minus 3, negative 15y. All right, so there's the one way. And I expect that many of you are probably going to do that. Is that okay? Definitely. Okay? Here's the other way. Is that because these are all multiples of my number, okay, or factors of that number, I can simplify them as I go. So, all right, you got to think a little bit here. 3 goes into 15 how many times? 5, okay? And 5 times 1 is, so we have 5y. All right, so how did I do that? So, okay, here's the denominator, is 3. 3 goes into 15 5 times. Okay? The next one, negative 3/5 x. 5 goes into 15 how many times? 3. So 3 times negative 3 is negative 9x. All right, do you see the difference? The next one is a 3 again. Oh, 3 goes into 15 how many times? 5. So 5 times negative 2 is negative 10y. Right. The last one is 15. 15 goes into 15 one time. So 1 times 4 is 4x. Right. So you have 2 options there. Okay? 1, multiply it out. 2, figure out how the denominator reduces it, and go from there. So we get negative 5x minus 5y. All right. So these problems are set up so that your denominator does go into that number you're distributing. Okay? And so you can simplify it that way. All right, so do 11 and 12.